Conductors or wires for electricity are manufactured in many different sizes, conductive materials, and insulations. The conductive material most used in electrical wiring is copper. Copper is an excellent conductor of electricity. It is highly malleable. In other words, it can be bent without breaking. It is also an excellent conductor of heat. Aluminum is a very good conductor of electricity, but not as good as copper, so it has more resistance for the same size or thickness and length of wire. It is also highly malleable. It is also a very good conductor of heat, but not as good as copper. Because aluminum is less expensive than copper, it is sometimes used instead of copper. The power company uses aluminum wire for power transmission lines. Aluminum will not corrode under normal conditions because it forms a thin invisible oxidation layer on its surface. The oxidation layer is aluminum oxide, or also called alumina. It protects the aluminum, but it is also a very good insulator. Special connectors or pastes must be used where aluminum connects to other wire, otherwise the oxide layer will create large amounts of resistance. The resistance can create heat, which may even result in a fire. The simplest type of wire is uninsulated wire. Uninsulated copper wire has many uses for fabricating jewelry and other things. But other than for ground wires which do not normally carry current, most electrical wires are insulated to prevent short circuits. Often wires are formed into cables that hold multiple conductors, which are each insulated from each other. The size or thickness of a conductor is specified by a number called the gauge. The American wire gauge, AWG, is used in the United States and other countries as a standard method of denoting electrical wire diameter. Increasing gauge numbers give decreasing wire diameters. This seemingly counterintuitive numbering is derived from the fact that the gauge number is related to the number of drawing operations that must be used to produce a given gauge of wire. Very fine wire, for example 30 gauge, requires more passes through the drawing die than does 0 gauge wire. Note that for gauges 5 through 14, the wire gauge is effectively the number of bare solid wires that, when placed side by side, span 1 inch. That is, 8 gauge is about 1/8 of an inch in diameter. The steel industry uses a different numbering system for wire thickness gauges for things like wire fence. Look carefully at this wire table. It lists the American wire gauge, or AWG, of some common wire sizes. It lists the diameter of each in inches. The table also lists the area in circular mills. A mill is 1/1000th of an inch, or 0.001 of an inch. A circular mill is also the cross-sectional area of a wire, 0.001 inches in diameter. The area of a conductor is found by squaring the diameter of the conductor measured in mils. For example, a wire that has a diameter of 50 mils would have an area of 50 times 50 equals 2500 circular mils. This chart also lists the resistance of each gauge of wire in ohms for 1000 feet. Notice that wire gauges have a smaller gauge diameter have less resistance for a given length of wire. Larger wires provide less friction for electric current. This chart also lists how much the wire weighs per 1000 feet. The price of copper has caused copper wire to become quite expensive in recent years. Metric measurements are used for wire gauge measurements in many countries of the world. There are equivalents for AWG wire gauges. For example, AWG 12 has a metric size of 2 millimeters. AWG 18 has a metric size of 1 millimeter. Electrical wire conductors are either solid or stranded. Solid wire, or solid core wire, consists of one piece of metal wire. Solid single-strand wire is cheaper to manufacture than stranded wire and is used where there is no need for flexibility in the wire. Solid wire also provides strength and protection against the environment. Stranded wire is composed of a bundle of small gauge wires to make a larger conductor, which may optionally be insulated. Stranded wire is more flexible than solid strand of the same total gauge. Stranded conductors are commonly used for electrical applications carrying small signals, such as computer mouse cables, and for power supplies between movable appliances and its power source. For example, a vacuum cleaner cord, a table lamp, powered hand tools, welding cables, and most other power cords. At high frequencies, current travels near the surface of the wire because of the skin effect, resulting in increased power loss in the wire. Stranded wire might seem to reduce this effect since the total surface area of the strands is greater than the surface area of the equivalent solid wire, but in fact a simple stranded wire will in fact have worse skin effect than a solid wire because of its increased average resistivity due to the inclusion of air gaps within the wire. Some wire is shielded by an outer conductor. Wires are shielded to prevent the wire inside from picking up interference from outside electric fields and radio signals. The braided copper signal also prevents the conductor inside from radiating an interfering signal. This coaxial cable is used to carry radio signals and has an outer insulator A, a shield B, an inner insulator C, and an inner conductor D. This shielded wire has several conductors inside. The inside conductors are each insulated with a different color of insulation. The shield is made out of aluminum foil. There is a small stranded wire for convenient connection to the outside shield. In a single conductor signal cable, the shield may act as a return path for the signal and is usually connected only at the signal source. In multi-conductor cables, the shield may be grounded, usually only at the source end, and will not carry electric current. By twisting two conductors of a signal circuit, some cancellation of inductively coupled noise is obtained. However, a metallic shield laid over the twisted pair provides even better suppression of noise. Some cables like Ethernet network cable and telephone cables use multiple twisted pair wires. The telephone company uses twisted pair wires to prevent the telephone signals from interfering with each other or from being interfered by outside signals like radio waves. Electrical wire uses both conductors and insulators to transmit both electric power and signals. Our modern technology would be not nearly as helpful if it were not for wires.